I think you're mainly referring to the reduction formula, like
Yeah.
180 plus, 180 minus, all that stuff, right?
Yeah.
Yeah, so that kind of work falls under the reduction formula. Actually. You see, the reduction formula. So the idea with the reduction formula is that it's a set of formulas that you don't have to cram. You see, if you're going to take away anything from what we're going to say, one thing I can say is don't cram these things. You need to be able to generate them. You see, it's almost like cooking an egg. You haven't crammed out cooking egg. You just know the steps. You see, you heat up the stove, you take out a pan, you put oil, you wait for the pan to heat up the oil, you check out the egg. If you want to beat it first in a bowl, you can do that and then put it in the pan. If not, you can do that. It's a choice. You put it in the pan, a few seconds later, it's done. You take it up. You didn't cram that. You see, it's something that you have just over time known how to do. You just generate the steps. You decide what you want to do as you go. If you want to add, I don't know, some pepper or some onions, whatever, you can decide that on the fly. So with the reduction formula, it's the same idea. You need to be able to just choose what you need to use as you're working on it. And this is how you do it. You firstly need to understand what the cast diagram represents. So the cast diagram works together with the standard forms of these equations. So if you have a sine graph, if you have a cos graph, and if you have a tan graph. So what I'm drawing here is the standard images of these graphs based on what we're likely to see from 0 to 360. You see, all this here is representing from 0 to 360. So, and we know this is in intervals of like maybe 90. So this is like 90, 180, 270. In the middle here, we have like 90. Middle there, we have 270. Here we have 90. Here we have 270. And then in the middle, 180. At the end here, 0. At the end here, 360. So this is something that you're familiar with, correct?
Yes, I'm familiar with that.
Cool. So the idea with these graphs is that they're called periodic graphs, mainly because they just repeat, going on and on and on. You see, this picture here just repeats, going on and on and on. Same as these here. A 10 graph is basically this part. You see, that's why they say the period is 180, the standard one, because from 90 to 70, that's a space of 180 degrees. So that's why this is half a 10 graph, because if it carries on, it's going to look like that. If this one carries on, it's going to look like that. With these other graphs, we know that if they carry on, they'll just, their shape just repeats, their shape just repeats. So the reduction formula needs us to consider how certain y values have multiple x values. For example, if you have an x value here, right, whatever it is, let's say it's like 45. You have to see whatever this y value is, right, it's going to be the same as this particular y value over there for a different x value, maybe like 135, something like that. Do you see that?
Yeah, I see that.
Yeah, so that way of thinking is how the reduction formula works. It basically works with the fact that these graphs repeat. So if you say things like 90 degrees, a specific x value, right? If you say 90 degrees minus, if you go back a certain amount of units, or if you go forward a certain amount of units, if it's the same thing, you're bound to just end up with the same y values. You see, stuff like that. And then with 180 plus and 180 minus, if you look at it nicely, if you're starting at 180 plus, if you go this direction, or if you go this direction, you could end up with this y value, you could end up with this y value. If you check what the y value is there, and you check what the y value is there, you'll find out they are the same number. One is a plus, one is a minus. You see, so that's the idea with what you call sine graphs, cos graphs, and trigonometric graphs in general. They repeat based on where you're looking at them in your Cartesian plane. So the idea is, without you now working with a sketch like this, which is, not very, I mean, it's not the best, most efficient way to do what we're doing. You now have this, the cast diagram. What the cast diagram says is that if you look at the standard pictures from 0 to 90, right? This is where you can put 0. And if you go anti-clockwise, you have 0, 90, 180, 270, and then back here you have 360. So what the law says is that with this diagram, right, you can call it a cast diagram. If you put C here, A here, ST, specifically, it has to be in this order. Now, what this order does is it tells you that between 0 to 90 degrees, all these graphs have positive Y values. And the pictures say that. You see, from 0 to 90, this has positive Y values. A cos graph also has positive Y values. A tan graph also has positive Y values. So that's what they mean when they say from 0 to 90, all of them are positive.
Okay.
Secondly, if you now move along with the diagram, the rest is also self-explanatory. Between 90 and 180, only sine is the one that has a positive Y value. It's the only one that has positive Y values, right? Between 90 and 180. These are positive Y values. And then here, if you look nicely, the rest have negative, you see? These are negative Y values. And then from 90 to 180, these are also negative, you see? You see, that's why here, between 90 and 180, only sine is a positive because it's linking with the sketch. If you carry on, the same is true for the rest of the images, you see, because from 180 to 270, from 180 to 270, only 10 has positive Y values. The rest have negative, you see, negative over here, negative over here. And last but not least, you have the what is this? The part where you just be talking about the cast, the C. The cos is the one that's positive from 270 to 360. Positive Y values, the rest have negative. So as long as you can at least understand that, you now have an idea of what you're applying and what it's trying to tell you. So the idea with the reduction formula is you'll be trying to work with expressions that are not very chunky, the bigger looking the expression, the more unfriendly it may look. So normally you want to work with something that looks, small and all that. That's what the reduction formula tries to do. It helps you to work with things that look smaller, because if they're smaller, you can break them down more and then get an answer. So in these different quadrants, you have different expressions, right? In the first one here, you can have 90 minus a reference angle, or you can have 90 minus, or you can have 360 degrees plus. You see, that's what you can have here. In this next one, you can have 90 plus, or you can have 180 minus. You see, in the next one, you can have 180 plus only, because you don't work with 270. It's more like some, it's more like this bed blood 270. So you don't work with it. For the course here, you will work with 360 minus. 360 minus. So the idea here is when you work with these expressions, right? Let me take it here. Let me go down here. So when you work with these expressions, this is all you need to remember. You see that there are only 3 sets of numbers here to deal with. There's 90, there's 180, and there's 360. So the idea is you have to just remember that when you work with 360 and when you work with 180, the trig ratio stays the same. You see, the trig ratio stays the same. That's the first thing to remember. Anytime you work with 180 plus or 180 minus or 360 minus or 360 plus, the trig ratio stays the same. After the trig ratio stays the same for 350 and 180, you obviously for 90, that's the only place where the trig ratio changes. You see, so
Yeah.
here, if you're starting with something like, let's say sine, let's say 180 minus. You see, this is going to be equal to sine theta. And the reason why we are saying it's a positive sine theta is because in the quadrant 180 minus something, sine is a positive. So you keep this a positive also. This was just an example. For the next one, if you are maybe working with something like sine 90 plus, this here, it is going to change to a cos. But then in the quadrant 90 plus, you see that sine is a positive. You see, the quadrant
Yeah.
90 plus sine is a positive. That's why here this has to be a plus. You change the ratio, yes, but because sine is a positive, you make this a plus and you put your angle there. You see?
Oh yeah, I see.
So the thing now is when you're dealing with 90 and you're dealing with 10, your safest bet is to do the following. If you have 10, let's say 10, let's see, 1090 plus theta. This you have to change it to sine on the top, you see, and then cos at the bottom. You see, because that's the ratio for 10.
Yeah.
And then once you do this, you work with them individually. Like the top, 90 plus, you already know that since you're dealing with 90, it has to change. And in the quadrant 90 plus, sine is a plus. So even though you change it at the top, you're gonna have to put a plus cos there. The bottom part, however, you're gonna change it to a sine, yes, but in the quadrant where you have 90 plus, cos there is a negative.
Oh yeah.
So that's why you're gonna put a negative because where you're coming from is cos, and cos is a negative in that quadrant. So now you know on 10, 90 plus something, it's just gonna be something like this. Should you ever need to use it, but it's quite rare. You see?
Yeah.
Yeah. So any other example, whether it's 360 plus, 360 minus, doesn't matter. As long as you're dealing with 360 or 180, your item stays the same. If you come from a cos, you become a cos. If you come from a sine, you become a sine. You always choose what goes here based on where you're coming from. You see?
Oh yeah, I see.
Yeah. So with that being said, the only other issue now is, you see, with all that we are talking about here, we are talking about it from a normal standpoint. You see, 180 plus, 180 minus, all that. When it's now switched up and you now have, let's say the angle coming first and then the variable coming first and then the number after. Say you have, let's say, sine theta minus 180, like that, you see.
Yeah.
In a situation like this, right, you have to remember that what you normally want to do is you can just use how this always works. You see here when you're dealing with these normal numbers, when you're thinking of something like 180 minus, you know that your cast diagram allows you to go 180 degrees, right? This is anti-clockwise. And then the moment you subtract, you have to go back. You see, this is what you know. 180 and then minus theta. That's what you do. So this is supposed to show you that if you have a plus, now a positive number, it means that you go anti-clockwise. If you're dealing with a negative, you go clockwise. You see, it makes your life easy. So that now when you're dealing with stuff like this, the first thing you have to do for yourself is swap around the theta and the 180. Swap around these two, but swap them around with their signs in front of them. So this is a minus 180. This is a positive theta. So that when you use the cast diagram, remember we said if it's a minus, you go clockwise. So negative 180 tells you to go negative 180. The moment you see this plus, it means you'll end up in this quadrant where 10 is a positive. So you already know that whatever this is, since it starts off as a sign, it's going to become a sign. But then in this quadrant, only 10 is a positive. So you have to put a minus there.
Okay.
You see, that's how you
Yeah.
deal with. That's how you deal with the negative stuff when it's mixed up. If it was mixed up and they were both positive, I mean, that's not an issue. You would just swap them around. You see that it's like 180 plus theta. 180 plus theta is this quadrant. You wouldn't have any issues there. You would still just be able to work out what you need to work out. So when they're now individuals, let's say you have sine negative theta or 10 negative theta. The reason why these are negatives is because when you see a cast diagram, remember we said negative means you go anti-clockwise. I mean clockwise rather. So here negative theta puts you in this quadrant where only cos is a positive. So that's why this becomes negative sine. That's why this becomes negative 10. And then that's why for the cos, it always still stays a positive. You see, because if you say cos, a negative theta is just doing negative theta. So you're going to end up in this quadrant. Wait,
Oh, yeah.
that's why they say cos with a negative angle stays as positive. But then the others, if it's a negative in here, it becomes negative in there. If it's negative in there, it becomes negative in there. You see?
Yeah, I see.
Do you see it? Yeah.
Yeah.
So what's important is if you're looking at these two things here, right? Remember that theta represents anything. It could be two things put together. Let's say you have sine negative 180 plus x. You see, you have to remember that this 180 plus the x, whether you initially did this on your own or it was given like that, who knows? So what I mean is, say maybe you're given negative 180 plus x and you want to work it out. You could do this route, right, of saying negative 180 and then you plus. So you'll know that you're going to end up with negative sign, whatever this whole angle is. I mean,
Yeah.
you know that you'd end up with negative sign with x. You know that
With
would be your
X,
answer.
yeah.
However, in some cases, maybe if you were to, let's say, take out a negative here, right? You would have 180 minus x here. And then you would have, you see here, this 180 minus x, it almost is in the place of this theta here. Do you see that?
Oh, yes.
Yeah. So what you know is sine with a negative anything is just negative sine. So you know that this would give you negative sine with whatever this whole thing is. 180 minus x.
Minus
And then as you
X.
look at this, if you say, remember, you should remember that you're dealing with this now. Don't mind the negative. The negative is already there. So when you will now say sine 180 minus x, 180 minus x lands you in this quadrant, right?
Yes.
Yeah, and this quadrant sign is a positive. So you'd say, okay, this here comes out as a positive, but then this minus was there to begin with. That's why you still end up with minus x. Whether you went the route of just going straight to minus sine x, or whether you did this, you end up at the same place, you know?
Yeah.
It doesn't matter what method you use. You just, the thing with trigonometry is you need to be flexible, because with trigonometry, multiple ways lead to the same thing. So when you'll see things in a memo that look different from yours, and what you did was correct, but your answers are the same, you don't want to panic and say, oh snap, you did something wrong. No, if you know it's correct, then it's correct. If you know it's wrong, then the answers won't match. You get it?
Yeah, I get it.
Yeah. So that's the long and short of the reduction formula. If you can remember these things that we just mentioned now, right, you're not going to have any issues with the reduction formula. Because now the thing is with the reduction formula, when they now add numbers, right? When they add numbers, it's a matter of you knowing that anytime they give you questions on questions that need you to use the reduction formula, they'll always give you numbers that you can, let's say, work out. If say they say don't use a calculator, they mean that the numbers they've given you don't need a calculator. So if you had to, let's say, simplify something like this, right? You already know that if they say simplify without a calculator, your first weapon is the reduction formula. And you would want to now break this up into two numbers that you can work with. So this 225 is like close to 180. So you could break it up into like 180 plus 45. You see?
45, yeah.
Yeah, which would be normally what you want to do, because normally you want to break it up into something that's a special angle, something that is not a special angle. I mean, you usually can break it up into a special angle and something that may be useful. You know, if it's a special angle also, you're lucky. If not, it means you can still break it up based on the expression. So here you know that 180 plus, it lands you in the quadrant where sine is what you may call a negative. You see, a 180 plus quadrant is here, right?
Yeah.
So you know that this is just going to be sine 45 with a negative, because since it's 180, if you're coming from a sine, it's a sine. 180 plus anything gives you a negative sign.
Negative sign.
Yeah.
Yeah.
And you know that based on your special angles, the 45-45 triangle allows you to know exactly what this is as a number without using a calculator. So you know that there's a negative there. Sine 45, you can use any 45, it will give the same thing. Opposite of hypotenuse, you can have 1 over square root of 2 like that.
Yeah.
Yeah. So that's the idea with these kinds of questions. You see, you need to just keep in mind that with the reduction formula, there's a method to the madness. And if you can just remember it like this, you will not have a problem with the reduction formula. Cool.
And what if they give you like a value